Now next sum, let's solve f of x equals to tanx. Okay, this we have to solve with the help of ab initio, or we call first principle. Okay, the concept is same. Since fx is given, we have to find of x plus f of x plus h, and then f of x plus h minus fx upon h, then take limit h tends to 0. That we have to find out. Okay, but for these we have direct formula. Differentiation of secx is differentiation of tan is what? Sec square x. We know this different derivative. But with the help of first principle, we need to find out what is differentiation of fx. Okay. Since f of x equals to tan x, then therefore f of x plus h will be what? Instead of x, we have to write x plus h. Okay. Therefore, this will be tan of x plus h. Okay. By first principle, what we have is limit of h tends to 0, f of x plus h minus f of x upon h. This is what? This is by first principle. Okay. This is by first principle. So now what we have to do? We have to substitute f of x plus h. This f of x is that, and take limit h tends to 0. Okay. This is same as limit of h tends to 0. What is f of x plus h is what? Tan of x plus h minus tan x upon h. Okay. Now I told you before, this is tan. Okay. Tan x plus h, tan x. Okay. Now whatever you have alternative functions, you try to bring it to either sine or cos. Okay. So in order to get the tan into sine cos, tan is what? Sine x upon cos x. Okay. We know that tan is sine x upon cos x. So we can write like this. Limit of h tends to 0. Instead of this, what we can do is sine of x plus h upon cos of x plus h minus sine of x upon cos x upon h. Okay. What I am doing, just I am, instead of tan, I am writing sine upon cos. Okay. Let's take LCM. Limit of h tends to 0. Now if we take LCM, this into this will come, this and this will cross multiply, and this will cross multiply. Okay. Here what we'll have, cross multiplication is sine of x plus h into cos x minus, and then what we have, cos of x plus h into sin x upon h. Okay. Upon this, upon what we have, cos of x plus h into cos x. This h I will write over here. Okay. Here. So same. This h is here. Same. Okay. Now remember, what we have is, we have some formula over here. Okay. H tends to 0. This is all for, let's consider x plus h is a. Okay. Sin a cos b, cos a sin b. Okay. Remember, we have sine of a plus b is what? Sin a cos b plus cos a sin b. This formula. Okay. Sin a plus b is sin a cos b, cos a sin b. It's consider this sin a cos b, cos a sin b. Okay. This is of the form sin of a plus b, means x plus h plus, what is x plus h is a and x is b. Okay. Here b, the whole this become a this by this formula. Okay. Upon what we have, cos of x plus h into cos x into h. Now here this twice, here the x plus x is what? Twice x. Limit of h tends to 0. What we have is sine of twice x plus h upon cos of x plus h into cos x into h. Okay. Now what we have is, we have sine of x plus, when h tends to 0, okay, when h tends to 0, these become a still 0, okay, this becomes still 0. Now what we have to do is, we have to we have to try to get twice x plus h over here. Okay, now here what we have is, we have sine a, let me explain again. Tan x plus h is this, okay, sine upon cos, sine upon cos. Since x plus h is there, x plus h, sine x is cos x. Okay, by taking LCM, this into this, sine of x plus h into cos x, cos of x plus minus, okay, this should be minus. Okay, so since minus is there, we will have, if it is minus, then minus will come. Okay, since minus is there, so minus will come over here, minus will come over here. So sine x plus h into cos x into h. Now these two will get cancelled. We'll have only sine h. Okay, now when h tends to 0, sine h upon h. Okay, this section, when h tends to 0, this section, okay, when h tends to 0, this sine h by h means limit of theta tends to 0, sine theta by theta is 1. Okay, this portion become 1. When h tends to 0, we are what have is only cos x plus 0, means cos x. Okay, cos x into cos x, what we have equals to 1 upon cos square x. 1 upon cos square x is what? Sec square x. Okay, therefore differentiation of tan is what? Sec square x. Okay, here if it is minus, then minus. If it is plus, then plus. Okay, now let's take another. Let f of x now 4. Let f of x equals to, we have done sin x, cos x, tan x. Let's do sec x. Okay, now f of x equals to sec x, then we need to find f of x plus h. Therefore, instead of x, what we have to do? We have to put x plus h. Okay, it will be sec of x plus h. Therefore, limit of h tends to 0, f of x plus h means what? We have sec of x plus h minus secx upon h. This is what? F of x plus h minus fx upon h. Okay. This is equals to limit of h tends to 0. Now I told you, whatever the derivative functions you have to bring it to either sine or cos. Okay, so sec is what? Sec x is what by cos x. So this is same as 1 upon cos of x plus h minus 1 upon cos of x upon h. Okay, now let's take is equals to, let's take LCM, limit of h tends to 0. Let's take LCM and cross multiply. This will come over here, will be cos of x minus cos of x plus h upon cos of x plus h into cos x into h. This h I'm writing over here. Okay, now it is when h tends to 0. Okay, now h tends to 0. Now this still whole is undetermined, means it's infinity. Okay, so we have to apply cos c minus cos d formula in order to bring into sine. So in order to bring into sine, okay, we have cos c minus cos d equals to minus 2 sine c plus d upon 2 sine c minus d upon 2. Okay, remember minus is there, so you have to write sine. Okay, now it's this is same as d minus c. If you want to remove minus, then it will be d minus c, or you can keep like this. Okay, now let's consider x as a c angle and x plus h as a d angle. Okay, this is same as limit of h tends to 0. It's minus twice sine of c plus d upon 2. Okay, c means what? x plus h upon 2 into sine of c minus d, x minus Here minus I am sending inside, minus h upon 2 upon, we have cos of x plus h into cos of x into h. Now what we have is, here this minus x and plus x gets cancelled, and it is equals to limit of h tends to 0 minus 2. Now here this same as x plus x is twice x, sine of twice x plus h upon 2. Okay, here sine of minus, what will come, minus h upon 2. Okay, we know that sine of minus theta equals to minus sine theta. Okay, now sine of minus h by 2, I can bring outside that minus, and this minus will get plus. Okay, over here, and this what will be sine of h by 2 upon cos of x plus h, cos of x h. Okay, now since sine of, we have formula limit of sine of theta upon theta, where theta tends to 0 is 1. Okay, so for this angle should be this angle, so I can bring these two down. Okay, here I can bring 2 down, these two I am bringing down. Okay, therefore this, when h tends to 0, this become a 1. Okay, when h tends to 0, sine 2x upon 2 is twice x, 2 gets cancelled, we have sine x. Okay, sine x upon cos x we have. Okay, and then what we have, when limit tends to 0, what we have sine x. Okay, and when x tends to 0, h tends to 0, what we have is, we have cos of x into cos of x. Okay, this cos x is there. When h tends to 0, this becomes 0. Twice x upon 2 is 2 gets cancelled, sin x. H tends to 0, this becomes a 0. So cos x into cos x. Okay, this is same as sin by cos is what? Tan x, and 1 by cos is sec x. Okay, now you can say this is same as sec x into tan x. Therefore, differentiation of sec x is what? Sec x into tan x. Okay. Now, next sum is fx is equals to cotx. Okay. We'll find out by first principle. Okay. Similarly, this fx is given, so we need to find out f of x plus h. Okay. And since cot is there, so we need to bring down into either sine or cos. Okay. And then by applying sin c or sin c plus sin d or cos c or cos d, so we have to split it, and let's try to bring into sin theta upon theta, where theta tends to 0. Let's see how it works. So now f of x is this. Now f of x plus h will be cot of x plus h. Okay, by first principle formula, limit of h tends to 0, f of x plus h means cot of x plus h minus cot of x upon h, where h tends to 0. Okay, why? Because this f of x plus h minus fx upon h. Okay, now from here, converting, cot is what? Cos by sine. Okay, so converting cos by sine, cos of x plus h upon sine of x plus h minus, similarly, cos of x upon sine of x upon h. Okay. Now by taking LCM, limit of h tends to 0. By taking LCM, this into this will come, and after that this into this minus this into this. Okay, so what we'll have is sine of x into cos of x plus h, this into this minus cos of x into sine of x plus h upon this into this, okay? Sine of x plus h into sine x. This h I am writing over here, okay? What I am doing is just I am taking LCM. Sine of x plus h sine x. Sine of x plus h sine x is here, okay? And this into this is here. We have minus this into this is here, okay? It is already form sine a cos b. It is already form here sine of a cos b minus cos a sine b, okay? This is our sine of a minus b. Sine of a minus b is sine a cos b minus cos a sine b, okay? Consider this is a, sine a cos b, cos a sine b, okay? Consider x as a, x plus h as a b, or this is already from this, okay? Therefore, this is already from this. Here, limit of h tends to 0. This will be sine of a. A is what? X, okay? Minus. Since minus is there, so you just put bracket x. What is b? X plus h, okay? Here I am taking bracket upon sine of x plus h into sine x into h. Here if I am sending minus inside, this x and this x will get cancelled. This x and this x will cancel, and I will have what? Minus of sine x, okay? Here limit of h tends to 0, I will have sine of minus h up, okay, upon, I will like this h over here, okay, and sine of x plus h into sine x. This h I am writing over here, okay, and sine of x plus h is sine of x plus h, and this x is here, okay. We know that sine of minus theta is minus sine theta, so I can bring this minus outside, okay. So if I bring this minus outside, minus limit of h tends to 0, sine of h upon h, this we have, okay, this we have. If I send this minus outside, okay, when h tends to 0, okay, when h tends to 0, this become a 0. So what we have? Sine x into sine x, okay. Here we have sine of x, the sine square x. Sine x here, because h, when h tends to 0, this becomes sine x into sine x is what? Sine square x, okay. Now this whole, this become a 1 when h tends to 0. What we have is minus 1 upon sine square x. 1 upon sine square is what? 1 minus cosec square x, okay. Therefore, if fx equals to cotx, if differentiation of cotx is what? Minus cosec square x, okay. Now let's take another example, or another formula. You can say f of x equals to cosec x, okay. Now what we need to find out? F of x plus h, okay. Since cosec x is this will be what? Instead of x, what we have to do? A cosec x plus h, okay. By first principle, we have by formula limit of h tends to 0, f of x plus h is this, cosec of x plus h minus f of x plus h minus fx, okay. Minus fx is what? Cosec of x upon h. What I'm doing is just applying, since formula f of x plus h minus fx upon h, okay. Now I told you before, whatever the trigonometric functions you have, either you bring into sin x or cos x, okay. Since cos x is what? 1 upon sin x, okay. So instead of cos x, I can write 1 upon sin x. This is same as limit of h tends to 0, 1 upon cosec x plus h minus 1 upon, instead of cosec, what we have to write? We have to write sin x, okay. Sine of this. upon sine of x upon h. Okay. Now, what to do after this? You take LCM. Limit of h tends to 0. By taking LCM, you have to multiply, cross multiply. So what we have is sine of x minus sine of x plus h upon, you have to multiply these two. Okay. What we have is sine of x plus h into sine of x into h. Be careful, what is your limit? Your limit is what? H tends to 0. Okay. H tends to 0, still it is indeterminate form, it's undefined. Okay. So what we have to do is we have to apply sine c minus sine d formula. Okay. You consider x as a c and x plus h as a sine d. I will write over here what is formula. Sine of c minus sine of d is equals to twice. Okay. Twice what I like first. Okay. Sine c plus d twice sine c plus d upon 2 cos c minus d upon 2. This is sine c plus d. Sine of c minus sine of d equals to twice cos first. Okay. Cos of c plus d upon 2 sine of c minus d upon 2. Okay. If it is cos c plus cos d, then it's become twice cos this cos cos. Okay. If it is sine plus sine cos, sine minus sine c minus this cosine. Okay. Now we have to apply this formula. This formula is equals to limit of h tends to 0. This becomes c, this becomes a d. What is our c? Our c is this and another d is this. Okay. Now twice cos of c plus d. Okay. C plus d upon 2 means x plus h upon 2 into sine of c minus d. Here x minus, since here plus is there. Okay. So I am sending minus inside. It will be minus x. Be careful. Okay. It should be minus h. Why? Because I am sending minus in outside. Okay. It will be minus x and minus h. Okay. Here c minus d. Okay. Upon 2. And what we have is in down sine of x plus h sine of x into h. Now this sine x and plus minus x will get cancelled, and these two I can bring down over here h by 2, these two. Okay. And consider this one, sine of minus theta. What we have only sine of minus h upon 2. Okay. So minus sine of minus theta is minus sine theta. So I can send minus outside. Okay. So let's write next one. Let of limit of h tends to 0. What we have when h tends to 0, this becomes 0. Okay. So cos of x plus x is what? Twice x. Twice x upon 2 is, we have only cos of x. Twice x upon 2. Okay. Upon when h tends to 0. Okay. When h tends to 0, this becomes 0. We have sine of x. Okay. Into sine x. Sine of x into here sine x. When here what we'll have is minus. Okay. Minus 1. Why 1? Because sine of minus theta is minus sine theta, and then what we have after that, sine of h by 2 upon h by 2. When limit h tends to 0, it become a 1. Okay. We already send minus outside here, therefore it will be minus. Okay. When h tends to 0, we don't have any h over here. So cos by sine is what? Cot. Cot of x into 1 by sine is cosec. Cosec x minus. Okay. Therefore, if fx equals to cosec x, then its differentiation is minus cot x into cosec x. Okay.